All right, we'll get started here. This week, you are going to rework the robot and get it all right. So everybody was close, but everybody has mistakes. So I'll show you those in a second. So rework the robot and also do a tutorial out of SolidWorks. I'll show you that in a second. So let's look at the robot. Mounts. So Jonathan's was the closest. You can see his initials here. It actually goes on extremely well. So that is perfect. So goes on, rotates, clicks into place. So that's perfect. So I'll give you those dimensions so you can all make those corrections. The inside slot there is the slot that's just too small on most of yours. So we'll measure that unless you remember it, Jonathan, what that number was.
This slot width?
Yeah, this inside slot. Okay, let's look. All right, let's see if I can get that. So it's very hard to measure, as you've all experienced, but how's it going? Yeah, this is measuring 180. So yeah, 190 is probably the right number because I can't really get in there perfectly. But like I showed you, his went on and spun nicely. And the rest of yours, some slid on, some didn't. But this inside slot was too small to rotate. So there was just no rotation. So 190 is what Jonathan did. Let's get them all corrected to that. Your diameter in here is perfect too. So that appears to be 2.30. I don't know if you remember that, but 2.30 is probably going to work fine. Where you missed, what? Yeah, so any of that should work. The only thing that Jonathan missed was this is just a little loose. And that, you know, that's us learning about the printer, you know, what the tolerances are. So whatever this is needs to be sized up. So this appears to be 0.835. Okay, so if it's a little bigger than that, we should work like maybe 850. If it's a little big, we can actually sand it, right? And get it tighter. So that's the only thing you need to fix on yours. So that's the first project, is to fix these, get them all to where they're gonna go and spin on. After I'm done talking, you can grab yours and grab these and see how it works, but that works really well. We're not gonna optimize them yet, but we will do that later. All right, so the other thing that you're gonna do is you're gonna work through this tutorial on the Simulation Express. So there's 3 sections to it. I want you to work all 3 sections. And when it gives you a part to work with, I want you to model the part. So what it tells you to do is go find the part and just work with it. But I'd rather you get the practice of modeling it. Now, they don't give you any dimensions, but you can see the part here, right? Just make up your own dimensions, model that thing up, and then do the Simulation Express to it. Read through this kind of carefully because you want the same, like this says the hook is made of alloy steel. So we want that same material, so our stresses are similar. So if you don't remember how to do that, it's in sensors. Actually, that's not it. It's in material right here. Right click on it, edit material. And then you can go through, and the steel one's always open. There's a lot of different steels, but then there is an alloy steel. What this is doing is bringing in the material properties of that material. So tensile strength, shear modulus, Poisson's ratio, elastic modulus, all of those things that we cover in strength of materials are being pulled in and applied to the part. So that's what we want. Your simulation is not going to be any good unless you do that. So what you're going to end up doing is running, putting some loads on, fixing some points. So they fix this point as the mounted fixed up point. And then running a simulation, which is basically a finite, I'm going to click forward, a finite element analysis of the part, giving you different levels of stress. So this is called the von Mises stress. And the red obviously is out of the range and blue is in the range. So, and then it gives you the yield strength here, which is something we wouldn't typically want to go over. Okay, so the simulation's pretty fun. You're going to do that one, and then you're going to do this one. So again, build this part and then work through the tutorial on how to fix a face, and then you're going to apply a load. Let's see where they put the load on this one. Just clicking forward, they have the load inside here. Okay. What else? Oh, on these parts, if you want to edit the material and make it ABS, that's what we're running in that machine. So get rid of that. It should be under, I haven't looked recently, where are the plastics? Yeah, I don't even see it. So there we go. Plastics and ABS. So you can look at the difference between ABS PC and ABS. There's not much difference, but just regular ABS. If you apply that, so now I have ABS to this material, it gives it kind of a little color, right? And then you can add a sensor, mass properties, and it'll give you the weight. So that's kind of fun. Once you have that done, then you can compare that weight, take your part to the scale and see how it compares to real life. So that's kind of fun, because the next thing we're going to do is try to cut weight and still have a functional part. So we're going to do the optimization first, and then we'll let the software do the optimization later. So we get a feel for kind of what it takes to do it. We have to think about like how we're going to print this and where we want to remove the material from so it's still functionable, right? And I showed you one of mine where I just put lightning holes in. That's great for optimization, but it's not really great for printing because it adds all that support material. The best thing for optimization is just to get rid of material that you don't need. So here you can see we got rid of some here, right? So maybe we could just keep doing that and get rid of more material and more material. All right, so then when you get this part redone, I want you to play with GrabCAD a little bit. So GrabCAD, and I've asked John to load it onto a few stations. I don't know if he's done it yet, but it is on this station, and it is on the station to the left of the 3D printer. So you can just email it to yourself or put it on a flash drive and walk it in there and then pull up GrabCAD and play with it. So I'm just going to walk you through how to do that. Add models. So wherever it is, you got to go find it. Yeah, make sure it's the right file type. It's got to be an STL. So to make an STL, you use SolidWorks and just save as and change it to STL. All right, so when it comes in, it'll come in all kinds of weird positions. That's fine. Roller mouse zooms you in and out. And for this software, whoops. For this software, doesn't matter where your mouse is to kind of get it to move around. The right click button is rotate, which is kind of odd, but it works, right? So then there's a couple ways you can arrange this thing. You can do it by hand, X, Y, Z axis. So you can figure that out, or you can do an auto orient. I usually do that just to see what it does. So notice it put these cuts up. If it would have put it down, that would have required support material underneath. So it does a fairly good job at auto orienting. It doesn't really think about the stack that well. So I'll get out of here and I'm just doing Control C and then Control V. So I'm just making copies. Control V. So if you wanted multiple of these, then you would go into Arrange, this one. And if you click Optimize, it's just going to arrange this tray for you. It doesn't really think about it that much, in my opinion, because I tried to do 5 and it couldn't make 5 fit. But then I made 5 fit just fine. So it's not great, but it does do something like that. So it did arrange them, right? So now if I go and go Control V, whoops, there we go. Bring it in. So then I can arrange that. Whoa, arrange, optimize. It'll do that, no problem. But then if I go Control V, bring another one in, which I think it should be able to arrange that, and it just doesn't do it. Optimize, arrange this tray. It actually just kicks one out. So what I did was hold the Control key down and you can grab 2 of them, and I just slid those over. Hold the Control key down, grab 2 of them, I slid these over. And then I put this guy in here. And it worked. So not real impressed with its ability to arrange. If I hit arrange right now, it'll actually toss it out again. So I think arranging on our own is probably the way to go. Yeah, it probably does. There's a little estimate button down here. So I'll hit estimate. 13 hours, 3 minutes to do those. Gives you model material and support material. So then I could go through a process of, trying to rearrange them or reducing numbers or something, right? But I just want you to play with it. You don't actually have to shoot a print. Once you get yours corrected, I'll shoot a print of the new 3 and we'll make sure they fit and work good. And then we'll go through a material reduction. Good. Fix the motor mount and work through the tutorials. That's the plan for today. I gave you due dates. Give you some time to do all this. So the rework is due 4/22. That's a couple days. And then all the tutorial work plus the parts is due 4/24. So that should do it.